Welcome back everyone. So this is the part 2 of the discussion we are having about basics of physics and electricity. So let's have a quick recall of session 1. Recall of lecture 1. So what we saw: stored energy is potential energy, correct? And moving energy is kinetic, correct? So the potential variable in terms of electricity is what? In terms of electricity, the potential variable is voltage. The units of that is volts. The kinetic variable is current. The unit of that is amperes. And what is the third most important point we saw? Energy flows from high potential to low potential. Always? No. Energy flows from high potential to low potential, true, if there is a path to flow. We saw that, right? If I have a tank in the building over the top, that does not mean that water will automatically flow down. Only when I open the tap, water flows down. If I close the tap, water does not flow down because there is no path for the water to flow. So for kinetic energy to potential energy conversion to happen, we need high potential and low potential. Not only that, it is not sufficient. And we also need a path from high potential to low potential for the energy to flow. These two together are needed. So this is a mandatory requirement. Correct? This is what? These are the key takeaways from the first discussion. Now let us go more into current electricity. Okay, let us go more into current and electricity. So what we saw: stored charge. Where we store the charge? Battery, correct? We store the charge in the battery. This is the potential, correct? So what is the symbol of the battery? We are going to show. All of you would have seen a battery, right? Yeah. So the symbol of a battery is this. The battery has a positive plate and a negative plate. This is the positive and the negative plate of the battery. This is the symbol of the battery. Okay. Now, flowing charge. What do we say? Let's say flowing charge is what? Current, which is the kinetic variable. Correct? Now, before we go to the flowing charge, I want to drag your attention to one important note. See, again, all these things we are going to learn by observation. Okay. Now I am going to play a sort of a mischievous game, you can think of. It's a game, but it's a very mischievous game. I have a balloon. All of you have seen a balloon, right? I have a balloon. What I'm going to do, blow air into the balloon. Blow air into the balloon. So what I'm going to do, so this is my balloon, okay? Initially it's like this, okay? This is my balloon. When I blow air into the balloon, it becomes like this, correct? Correct? This is balloon filled with air. Okay, correct? So, or rather, if I little bit alter the words and play with English, I can say, if I close this, let's say I blow the air into the balloon and I close the mouth of the balloon. So this is balloon storing air. Means what? Now you see I'm going to play with me. Storing means what? Potential energy. Okay. Now from here, I am going to do two things. Okay. Now what I'm going to do is take a pin and poke the balloon. What will happen? I'm going to take the pin and poke the balloon. What is going to happen? Abrupt release of potential energy. Correct? Balloon bursts. Correct? You have so much of stored energy. When you prick it, what happens? The entire air it's inside the balloon comes out of the balloon in one shot. Correct? So the balloon bursts out. It's abrupt release of potential energy. Correct? Because you try to bring the entire air into the inside the balloon, out of balloon in one shot. So the balloon sort of bursted open. Correct? So, correct? Now, after this, balloon is unusable. Balloon is unusable. Okay? This is what happens at the end. Now, instead of this, let me do something else with the balloon. Let me try to do something else. What am I doing? Open the mouth of the balloon. Open the mouth of the balloon. If I open the mouth of the balloon, what is going to happen? Air flows out. Correct? Yes or no? Air flows out. So here also air flow out. Correct? Whatever was inside the balloon, when you poke the balloon, the air inside the balloon came out. Here also, when I'm opening the mouth of the balloon, the air which is inside the balloon is coming out. So what is the difference? Here, air flows out in a controlled manner. Correct? This is very, very important. Air is flowing out here also, air is flowing out here also. What is the difference? Here the difference is air is flowing out in a controlled manner. That is the most important point. Air flows out in a controlled manner. So, what is happening? Potential to kinetic energy conversion is happening. Correct? Because inside pressure is more or potential is more, the water is flowing, the air is flowing out of the balloon. So the flowing out air has kinetic energy. Correct? Now the most important point, balloon is safe and can be used again. Correct? The balloon is safe and it can be used again. Correct? Are you guys understanding the difference between this? Here, when you release the when you abruptly release the energy, the balloon bursts open and the balloon is unusable again. Whereas, when you gradually release the air from the balloon is safe. The balloon is helping the potential energy to kinetic energy conversion, and it is safe and can be used again. Correct? Now I am going to replace the balloon with the battery. Replace balloon